All right, in this video, we're going to talk about section 2.4, dealing with more on slope. Okay, now in section 2.3, in the last video, we did talk about linear functions and slope. Now we're going to extend this with more information about slope. More than likely, we're going to be finding slopes of parallel and perpendicular lines. And then we're going to find the function's average rate of change. So those are only two things we'll discuss in this video. Okay, let's talk about slopes of parallel lines first. If two non-vertical lines are parallel, then they have the same slope. And what do I mean by parallel lines, by the way? Is this pretty much the best way to show you what parallel lines are is just an illustration. Let's say we have these two lines here. I'm going to call this L1 and this L2. Okay. So as you can see here, those two lines are parallel because they're not going to intersect at a point. They're not going to intersect anywhere at a point. And we can write this as L1, and this the symbol for is parallel to L2. So line 1 is parallel to line 2. And if two distinct non-vertical lines have the same slope, then they are parallel, okay? So we know that if these two are parallel, that means they're going to have the same slope. Also, if they have the same slope, then that means that the two lines are going to be parallel. And two distinct vertical lines with undefined slopes are parallel. In other words, so if I have two vertical lines like these two here, they are vertical lines. That means they're also parallel as well because they both have slopes that are undefined, if you recall. Okay. Now let's look at example 1. In this case, we're going to write an equation of the line passing through the point 3, -7, and parallel to the line whose equation is y is equal to -4x plus 3. And we're going to express the equation in point slope form and slope intercept form as well. So we're looking for an equation of a line that has this given point, 3, -7, and is parallel to the line whose equation is this, y equal -4x plus 3. And I'll go ahead and include the point 3, -7. Well, that equation is in slope intercept form, y equal mx plus b. So we can easily identify the slope. And the slope, if you recall from the last video, is the coefficient of your linear term or the coefficient of your x term. In this case, your slope is -4. And I'm going to label this as M1, the slope of the first line. So for the slope of the second line, keep in mind you have two non-vertical lines. If they're parallel, that means you're going to have the same slope. So if the slope of the first line is -4, the slope of that second line must also be -4. Okay. So here we're going to use the slope of the second line, which is -4, and this point 3, -7. If you recall, x1 would be 3 and y1 would be -7. We're going to use the point slope form. If you recall the point slope form, it is this: y minus y1 is equal to m times the quantity x minus x1. And then we're going to substitute the m the x1 and the y1 in this equation. And actually, we're going to substitute the m using m2, which is -4, the slope of the second line. So we're going to have y minus y1, which is -7, equals m, the slope that's -4, times x minus x1, which is 3. Now, if I write y minus 7, y minus -7 is y plus 7. That would be equal to -4 times the quantity x minus 3. This is considered to be point slope form. Point slope form. And then next we use a distributive property here. Bring down the y plus 7. That's equal to -4 times x is -4x. Minus -4 times a minus 3 will be a plus 12. And of course, slope-intercept form is where the equation is solved for y. That means we need to get y by itself by subtracting 7 on both sides. That would mean y is equal to -4x plus 5. And that is your equation in slope-intercept form. I might as well mention that here. Slope-intercept form. Okay. All right, let's try the second example. Here I want to write an equation of the line passing through -2, 5 and parallel to the line, whose equation is y is equal to 3x plus 1. And we're going to express the equation in point slope form and slope-intercept form. Okay. So now we got the equation y equal 3x plus 1. And the given point is -2, 5. All right, in this case, we need to identify the slope of this line. I'm going to call that M1, which is, of course, 3. Your slope, again, is the coefficient of your x term. And it does say parallel to the line. So if this slope is 3 for this equation, then the slope of the second equation also has to be 3. Because when you have parallel lines, that means you have the same slope. So now we're going to use this slope along with the point 2, -2, 5 in our point slope form, which is y minus y1 equals m times the quantity x minus x1. So now, x1 is -2, y1 is going to be 5. So in this case here, this will be y minus y1, which is 5, equals, the slope is 3 times x minus x1, which is -2. Now, x minus a -2 is going to be written as x plus 2. So this is what I have. Y minus 5 is equal to 3 times the quantity x plus 2. This is your equation in point slope form. All right, now the next step is to write it in slope-intercept form. So I'll just go ahead and finish this out. Bring down the y minus 5. That's equal to multiply 3 times the quantity x plus 2. This will be 3 times x, which will be 3x. Then 3 times the plus 2 will be plus 6. And then to solve for y, we're subtracting 5, so I need to add 5 on both sides. So that means I'm going to have y is equal to 3x plus 11. Y equal 3x plus 11 is your equation in slope-intercept form. Okay. All right, next we'll look at slopes and perpendicular lines. Slopes and perpendicular lines. And that's this. If two non-vertical lines are perpendicular, then the product of their slopes will be equal to -1. Now, what do I mean by perpendicular lines? Okay, let me show you an example of that or an illustration of perpendicular lines. Here I'm drawing one line, and here's the second line. There are two lines that intersect at what we call a right angle. And a right angle is going to be an angle measure of 90 degrees. That's where this box comes in. That's a right angle. And the illustration or the notation for that, if I let this be L1 and this be L2, then L1 would be perpendicular to, that's the symbol for is perpendicular to L2. Right, that's what we mean by perpendicular lines. And if the product of the slopes of two lines is -1, then that means that the lines are going to be perpendicular. So if I have a slope here and a slope here, if I multiply those two slopes together, if the product is -1, then that means these two lines are perpendicular. Now, a horizontal line having a 0 slope is perpendicular to a vertical line having an undefined slope. Illustration of that would be, here's a horizontal line, and then we got a vertical line like this. I'll call this L1 and this vertical line L2. They're perpendicular to each other. The horizontal line has a 0 slope. The vertical line has an undefined slope. So those two will be perpendicular. Okay. One line is perpendicular to another line if and only if one slope is what we call the negative reciprocal of the slope of another line. Here's an example of that. So if the first line has a slope of 2/3, the second line that's perpendicular to the first would be this, -3/2. We just take the reciprocal, change the sign to the opposite. Okay. And we're going to look at a couple of examples of just that. In example 3, we're going to find the slope of any line that is perpendicular to the line whose equation is x is equal to 5y minus 10 is equal to 0. That's part A. And then in part B, we're going to write the equation of the line passing through -2, -6, and perpendicular to the line whose equation is x is equal to x plus 5y minus 10 is equal to 0. And also we're going to express the equation in general form, ax plus by plus c is equal to 0. So here's what we're going to do here. We're going to start with part A. Let's find the slope of x plus 5y minus 10 equal to 0. All right, in this case here, we need to get the y by itself, meaning I need to move the x and the minus 10 over to the other side. All right, so let's move this x over to the opposite side by subtracting x on both sides. And not only that, We're subtracting 10. Let's go ahead and add 10 to both sides as well. Do all of this in one step. So that means I'm going to have 5y here, and that's equal to negative x plus 10. And then to solve for y, we're multiplying by 5, so let's divide each and every term in this equation by 5. So that means we're going to have y is equal to, and there's a 1 in front of the x, so this is like negative 1/5 x. Plus 10 divided by 5 will be 2. So that's the equation in slope-intercept form. Y equal negative 1/5 x plus 2. And the reason why I had to get the y by itself, because I want the equation in slope-intercept form. That way I can identify the slope. So here the slope of this first equation is the coefficient of the x term, negative 1/5. Now, the slope of the second line has to be perpendicular to the first. So here in this case here, I got the slope of negative 1/5 for this first line. So to find the second line, I need to take the negative reciprocal of that. The reciprocal of 1/5 would just be 5. And since it's a negative, I take the opposite, which is a positive. So that slope of the second line that I'm looking for will be 5. So now in part B, I'm going to be using the 5 as our slope and the given point, which was -2, -6 in my point slope form. Y minus y1 is equal to m times the quantity x minus x1. So in this case right here, your x1 is -2, y1 is -6. And we do our substitution here. So here we're going to have y minus y1, which is -6, equals the slope we're using, the perpendicular slope of 5 times the quantity x minus x1, which is -2. Now let's simplify this a bit. Y minus the -6 will be y plus 6 is equal to 5 times the quantity x minus a -2 will be x plus 2. Now remove the parentheses on the right side. Here's what we'll have. Y plus 6 is equal to 5 times x, or 5x, plus 5 times 2, which is 10. Now, they want us to express the equation in general form, meaning I need to move all the terms on one side and have a 0 on the other side. Let's move the y plus 6 over to where the 5x plus 10 is. And I'm doing that because I don't want this 5x to be negative. So let's move the y over by subtracting y. And let's move the plus 6 over by subtracting 6. So I have a 0 on this side. This will be 5x. On the other side, I'm going to put the minus y in front and then do 10 minus 6. That'd be plus 4. So this will be 0 is equal to 5x minus y plus 4. But the best way to write it would be this: put the 5x minus y plus 4, then that's equal to 0. That's the best way to write it. So this is your equation written in general form. Okay, let's look at example 4. Here we're going to find the slope of any line that is perpendicular to the line whose equation is x plus 3y minus 12 equal to 0. Part B is to write the equation of the line passing through -2, -6, and perpendicular to the line whose equation is x plus 3y minus 12 equal to 0, and express the equation in general form, which is ax plus by plus c equal to 0. So let's write that equation x plus 3y minus 12 equal to 0. So first of all, I want to solve for y because I want the equation in slope-intercept form so that I can easily identify the slope. Let's move the x and the minus 12 over to the opposite side. I'm going to do that by subtracting x on both sides. I got minus 12. I need to add 12 on both sides of this equation. So here I'm going to bring down the 3y. That'd be equal to negative x plus 12. And then to solve for y, I'm multiplying it by 3, so I need to divide each and every term in this equation by 3. So that means I have y is equal to, this would be negative 1/3 x plus 12 divided by 3. That'd be 4. So here's my equation, y is equal to negative 1/3 x plus 4. And now I need to identify the slope of that equation, which is in this case the coefficient of your x term, negative 1/3. So the slope of the line that's perpendicular to it, I have to take the negative reciprocal of negative 1/3, which is 3. 1/3, you take the reciprocal of that is 3, take the opposite of a negative, which is a positive. Because if you multiply negative 1/3 times 3, you're going to get negative 1. And for you to have two lines to be perpendicular, the product of the two slopes must equal negative 1. So that's part A. Now part B. We're going to use that perpendicular slope of 3 and the point -2, -6 in my point slope form. Y minus y1 is equal to m times the quantity x minus x1. So in this case here, x1 is -2, y1 is going to be -6. So here I'm going to do my substitution here. I got y minus y1, which is -6, equals to m, which is 3, times x minus x1, which is -2. So y minus a -6, that's the same as y plus 6, equal to 3 times x minus a -2 would be x plus 2. On the right side, I'll use a distributive property. So if I bring down the y plus 6, that's equal to 3 times x, that's 3x, plus 3 times 2, which is 6. And now to solve this equation for y, well, let's do this. We're writing it in general form, so that means I need to move the y plus 6 over to the opposite side. So I'm going to subtract 6, and I'm also going to subtract y on both sides. So I'm going to have a 0 on this side. That will be equal to 3x. My plus 6 and the minus 6, they're gone. And then minus y. So I get 0 is equal to 3x minus y. But I'm going to put the 3x minus y in front and then the 0 behind it. So this is my equation in general form. Okay. All right. Next, we'll look at the average rate of change of a function, because sometimes a function doesn't necessarily have to be a straight line. It could be a curve like this one right here. Now, the line that you see right here is what we call the secant line, okay? No, that's not clear here, but I'll write the word out, secant line. That's just simply a line that they use that crosses through a curve at two different points. And if you plan on taking calculus, you're going to see this word pop up, the secant line. And not only that, you're going to be required to find the equation of the secant line. All right, but here we're going to be looking for the average rate of change of a function. Here I'm going to let x1 and f of x1 and x2, f of x2 be distinct points on the graph of a function f. Now, the average rate of change of f from x1 to x2 is going to be this, f of x2 minus f of x1, all divided by x2 minus x1. Similar to the slope form, but pretty much you're looking for the slope of this secant line. That's what we'll be looking for. And let's look at some examples of this. In this case, here we're going to find the average rate of change of f of x is equal to x squared plus 2x from these 2 points, x1 being 0 and x2 being 1. All right, in this case, we need to find out what f of x is at those two values, x1 being 0 and x2 being 0. We need to evaluate f of x1. And x1 is 0, so this is f of 0. And we take 0 and substitute it and put it in place of x in this f of x function. So you're going to have 0 squared plus 2 times 0. Well, 0 squared is 0. 2 times 0 is 0. 0 plus 0 is 0. And now we need to find f of x of 2. And x of 2 is 1. So we're going to be evaluating f of 1. So here in this f of x function, we're going to substitute each x with 1. So in this case here, this will be 1 squared plus 2 times 1. 1 squared will be 1. 2 times 1 will be 2. 1 plus 2 is 3. So f of x2 is going to be 3, and f of x1 will be 0. So now we're going to be using an average rate of change, which is, of course, f of x1 minus f of x2 divided by x2 minus x1. My f of x, I'm sorry, this should be f of x2 because the y's have to correspond. F of x2 minus f of x1. F of x2 is going to be 3 minus f of x1 is 0 divided by x2 minus x1, 1 minus 0. 3 minus 0 is 3, 1 minus 0 is 1, 3 divided by 1 is 3. So the average rate of change for this given function is going to be 3. Now in part B, we're going to use that same function f of x for x1 being equal to 2 to x2 equal to 3. We're going to find the average rate of change. So first of all, I need to know what f of x1 is, and in this case, it's f of 2, because that's what x1 is equal to 2. Substitute your x with 2 in that function, you're going to have this. 2 squared plus 2 times 2. 2 squared will be 4. 2 times 2 will be 4. And 4 plus 4 is 8. And now for f of x2. And x2 is 3, so we're going to be looking for f of 3. And again, substitute your x with 3. This will be 3 squared plus 2 times 3. 3 squared or 3 times 3 is 9. Plus 2 times 3 will be 6. 9 plus 6 would be 15. And then we use our average rate of change formula, f of x2 minus f of x1, all divided by x2 minus x1. Okay, so here f of x2, that's 15, minus f of x1, that's 8, divided by x2 minus x1, 3 minus 2. And that's equal to 15 minus 8 is 7. 3 minus 2 will be 1. 7 divided by 1 is 7. So the average rate of change is 7 for this function. Okay. Now let's look at part C. Here we want to find the average rate of change for this function from x1 equal to -3 to x2 equal to 0. So let's start with f of x1, and x1 is -3, so we're going to evaluate f of -3. We're going to substitute each x with -3, so that means -3 squared plus 2 times -3. -3 squared is -3 times -3. That's 9. 2 times the -3 would be -6. 9 minus 6 is 3. And then for f of x sub 2. F of x sub 2. And x sub 2 is 0. So we evaluate f of 0. Now, I think we already did that up here, back in part A, what f of 0 is. That is 0. And now we use our average rate of change formula, f of x2 minus f of x1 divided by x2 minus x1. F of x2 is 0 minus f of x1 is 3 divided by x2 minus x1. 0 minus -3. And in this case, 0 minus 3 is -3 divided by 0 minus a -3, or 0 plus 3. That's going to be 3. And then -3 divided by 3, -1. So here the average rate of change for this function from those two x values will be -1. Okay, here's the last example for this video. Here I get f of x is equal to x cubed. Here I want to find the average rate of change of that function f of x equal to x cubed from x of 1 equal to 0 to x of 2 is equal to 1. All right, let's find f of x1. And x1 is 0. And all we do there is just substitute the x with 0. So this will be 0 cubed. That's going to end up being 0. And then f of x2 That's simply f of 1. Substitute the x with 1, so this will be 1 cubed, which is 1. And then we use the average rate of change, f of x2 minus f of x1 divided by x2 minus x1. So f of x2 is 1 minus f of x1 is 0 over x2 minus x1, 1 minus 0. Well, this is easy. This will be 1 divided by 1, or just 1. So between 0 and 1, the average rate of change for that function would just be 1. All right, now part B, x1 is 1 to x2, which is 2. So let's find f of x1. And x1 is 1, so f of 1, which we already found in part A, that's going to be 1. Now for f of x2, x2 in this case is going to be 2. So we're going to find f of 2. Substituting the x in the f of x function with 2, this will be 2 to the third, or 2 times 2 times 2, which is 8. And then again, use our average rate of change. All right, f of x2 is 8 minus f of x1, which would be 1, divided by x2 minus x1, 2 minus 1. 8 minus 1 is 7, divided by 2 minus 1, which is 1, and then 7 divided by 1 would be 7. So from x1 being equal to 1 to x2 equaling to 2, the average rate of change for the function f of x equal to x cubed would be 7. And then finally, x1 equals to negative 2 to x of 2 equal to 0. And so let's begin by finding f of x1. And x1 is negative 2. So we need to evaluate f of negative 2 by substituting the x in this f of x function with negative 2. So we got negative 2 cubed, which is negative 2 times negative 2 times negative 2, or negative 8. And then we're going to find f of x of 2. And in this case, f of x of 2, well, x of 2 is 0, so we need to evaluate f of 0, which we already found in part A. F of 0 was evaluated to be 0, so let's use that. And then our average rate of change is f of x2 minus f of x1 divided by x2 minus x1. Let's see, f of x2 was 0, minus f of x1 was negative 8, divided by x2 minus x1, 0 minus negative 2. 0 minus a negative 8 is 0 plus 8, or 8, divided by 0 minus a negative 2, or 0 plus 2, is 2. So 8 divided by 2 would be 4. So from negative 2 to 0, the average rate of change for the function f of x is equal to x cubed would be 4. Okay, so that's how we find the average rate of change of any function, which is similar to finding the slope from 2 given points. Here in this case, because it's a function, is not a linear function, you know your slopes are not going to be the same. It's just going to be different from just 2 given points. Okay. All right, so that concludes this video on section 2.4, which provides more information on slope. Feel free to email me if you have any questions about any of the examples in this video, or if you have questions about the homework in my math lab.